Hello ATS 113 students, Dr. Shragi here, and this is the first lecture in ATS 113, also known as Environmental Sciences 113. And I decided today to record the lecture outside. It's just a really pretty day. I apologize for the birds and the sounds of the neighbors mowing the lawn and stuff like that, but I think that we're all going to enjoy having a class outside, even if it is sort of a virtual class outside today. On this first day of the lecture, we do the kinds of things that frankly all basic science, basic anything, philosophy or whatever type classes do. We kind of define the problem and so on that we're going to be talking about in this semester of this course. And though it's a little bit cheesy, but we're going to be talking today about a few basic ideas. We're just going to give a very brief overview of the atmosphere in general. We're going to talk about things like what is meteorology versus what is atmospheric sciences and so on. And then we're going to talk about what the atmosphere is made of, what kind of gases go into the atmosphere, where do they come from, where do they go, how long do they last in the atmosphere, and so on. And then finally we're going to have a section that's going to be about the origin of the atmosphere. Why does Earth have an atmosphere at all? I mean, the moon doesn't have one. How did it come to pass that the Earth had an atmosphere? So we're going to start then with this sort of overview of the Earth's atmosphere. And as much as so much of our lives depends on the atmosphere, it's actually kind of amazing how small the atmosphere is compared to the big ball of rock that we are on. Some printings of the textbook in the past have gotten all bogged down in this idea that the big ball of rock that we live on is called the lithosphere. Don't worry about that word. In contrast to the atmosphere, which is the big ball shape of gas that we breathe and need for life. And that ball of gas, that atmosphere that covers the Earth, is actually really small. In fact, your textbook likes to point out that there's sort of an analogy here. If the size of the atmosphere is to the size of the Earth, as the skin of an apple is to the size of an apple. I mean, it's just this very thin little shell of gases perched on top of a very large ball of rock. In the same way, there's just a very thin apple peel on top of a lot of apple that you would eat or whatever. There is no actual top, though, to the atmosphere. It might give you that analogy might give you the sense that there's sort of a top, how high up you can go in the atmosphere, but actually there is no well-defined top. About 90% of the mass of the Earth's atmosphere resides below about 16 kilometers, and your textbook throws out some of these numbers like this, and different printings have slightly different numbers, but certainly once you get to, say, 100 kilometers up, virtually 100% of the mass of the Earth's atmosphere is below that. Now, when we do the vertical structure of the atmosphere lecture, which is coming up shortly, you'll see that there are, in fact, parts of the atmosphere. There are gases that continue up higher than 100 kilometers, but 100 kilometers is a good round number if you wanted to say just how high up does the atmosphere extend. Beyond about 100 kilometers up, for all intents and purposes, you are in space. Now again, because it's the first day of a class, one of the things that you always do on the first day of class is sort of define your terms. What is philosophy? What is theology? In that sense here, we're going to ask, well, what is meteorology and what is atmospheric sciences? I mean, we're in a class called that. We better make sure we understand what the difference is and so on. Well, I got out of your textbook this definition. It said that meteorology is the study of the atmosphere and the processes that cause weather. Now, I was a little surprised when I saw that definition. I've been doing this for a long time, and I gotta say, that did not sound like meteorology to me. In fact, if I were going to be, telling you a definition here, and I am, and if I looked at other textbooks, which I did, I'd say we could cross out that word meteorology. That doesn't sound right to me. I would say atmospheric sciences are the study of the atmosphere and the processes that cause weather. You probably have noticed that this course is called Atmospheric Sciences 113, not Meteorology 113. And in fact, if I were going to say, if I were even going to make a little bit more adjustment to that definition, I'd actually say that I'd add the words "and climate" at the bottom there. I'd say that atmospheric sciences are the study of the atmosphere and the processes that cause weather and climate. That's what we're going to be doing all this semester long. We're going to be learning about the processes that cause weather and climate. What causes weather to happen, what causes the climate to be what it is, and so on. Just to be clear here, weather is distinct from climate in that weather is sort of a short time scale phenomenon, like what's happening right now, which is very different from climate, which is sort of the long-term average. What is a typical day at this time of year here versus what is today's afternoon high going to be? Weather is the short term, what's going on right now. Climate is the long term, usually over a period of like 30 years. What was the on such a beautiful spring day, what is the typical high temperature? Or what is the typical amount of precipitation to be expecting or whatever?